AI is not software, it's infrastructure. Most people think AI is an app, ChatGPT, Midjourney, Copilots. But that's like thinking the internet is just Google. AI is becoming something much bigger. According to NVIDIA's thinking about the future of computing, AI is not just a tool, it is infrastructure. The same kind of infrastructure as electricity, railways, or the internet itself. And once you see AI this way, the entire industry suddenly starts making sense. For most of computing history, software worked in a very simple way. Humans wrote instructions, computers executed those instructions. Everything was pre recorded, data had to be structured, stored in databases, retrieved through queries. That is why SQL became the backbone of modern computing. But AI breaks that model completely. For the first time, computers can understand unstructured information. They can read text, they can see images, they can hear sound, they can interpret meaning, and most importantly, they generate intelligence in real time. Every response from an AI system is newly created. It is not retrieved from a database, it is generated on demand. And because intelligence is produced in real time, the entire computing stack had to be reinvented. NVIDIA describes this transformation using a simple framework, a 5-layer stack, or what we can call the AI layer cake. Energy, chips, infrastructure, models, applications, every AI system in the world sits on top of this stack. Let's break it down. At the very bottom of AI is something extremely physical, energy. Every word an AI model generates requires electricity. Every token produced is the result of electrons moving through hardware. Training large AI models consumes enormous power. Training models at the scale of GPT-4 can require tens of thousands of GPUs running for months. That is why companies like Microsoft, Google, and Amazon are investing heavily in nuclear energy, renewable energy, and dedicated power infrastructure. In the AI world, energy equals intelligence capacity. The more power you have, the more intelligence you can generate. Above energy comes the second layer, chips. This is where NVIDIA dominates. Traditional CPUs were designed for sequential tasks, but AI requires massive parallel computation. That is why GPUs became the backbone of modern AI. NVIDIA's 100 and B100 GPUs are essentially engines designed to convert electricity into intelligence. They process massive matrices simultaneously. They move enormous amounts of data between memory and compute, and they allow thousands of operations to happen at once. Without this chip revolution, the AI revolution simply would not exist. Above chips comes infrastructure, and this is where things become industrial. AI doesn't run on one computer. It runs on data centers with tens of thousands of GPUs connected together. NVIDIA calls these facilities AI factories, factories designed to manufacture intelligence. Companies like Microsoft, Amazon, Google, and Meta are spending tens of billions of dollars building these AI factories. These centers require land cooling systems, power grids, fiber networks, liquid cooling pipelines, server racks. They are closer to industrial plants than traditional data centers, and thousands of skilled workers are required to build and operate them. Electricians, pipe fitters, network engineers, technicians. The AI economy is not just software, it is physical infrastructure. Above infrastructure come the models. These are the AI brains. Examples include GPT models, Claude, Gemini, Llama, DeepSeek, R1. These systems learn patterns from enormous datasets, but language models are only the beginning. Some of the most transformative AI systems are emerging in areas like drug discovery, protein folding, chemical simulation, robotics, and autonomous driving. DeepMind's AlphaFold solved the protein folding problem. Tesla is training massive models for self-driving vehicles. Robotics companies are building models that allow machines to understand the physical world. AI models are becoming the reasoning engines of modern technology. Finally, at the top of the stack, we have applications. This is where real economic value is created. AI copilots for programmers, AI tools for marketing and design, autonomous vehicles, drug discovery platforms, industrial robotics, customer service automation. A self-driving car is essentially an AI application inside a vehicle. A humanoid robot is an AI application inside a body. The stack beneath them remains the same: energy, chips, infrastructure, models, applications. Every successful AI product pulls demand from every layer below it. When ChatGPT exploded in popularity, demand surged for more GPUs, more data centers, more electricity. Applications drive the entire stack, and we are still early in this transformation. So far, the world has invested a few $100 billion into AI infrastructure, but analysts estimate that trillions of dollars will be required. Around the world, we are now seeing semiconductor factories, massive data centers, AI supercomputers, and new energy projects built specifically to power AI. This could become the largest infrastructure build-out in human history. Another surprising outcome is the workforce demand. AI factories require people: electricians, technicians, construction workers, network engineers, operators. Many of these are high skilled, well paid jobs that do not require PhDs. AI is not just replacing work, it is reshaping work. Take radiology, for example. AI can now help analyze medical scans, but hospitals are not firing radiologists. In fact, demand for radiologists is growing because a radiologist's purpose is to care for patients. Reading scans is only one task along the way. When AI takes over routine work, doctors can focus on judgment, communication, and patient care. Hospitals become more productive, they serve more patients, and growth expands the workforce. This pattern repeats across industries. When you look at AI as infrastructure, the entire story becomes clearer. AI is not just software, it is an industrial transformation. It reshapes energy systems, chip manufacturing, data centers, scientific research, and entire industries. Every country will build it, every company will use it, and we are still in the early innings. The real question is not whether AI will reshape the world, the real question is this: who will build the layers of the stack and who will only consume them?